All right, welcome everyone. I'm Anu Narayanan. I am the Associate Director of RAND's National Security Research Division, or NSRD. NSRD advances understanding of pressing national security threats and develops policies and strategies to help mitigate and defend against those threats. First, a couple of housekeeping items before we begin. We are recording this webinar. We'll have time at the end for a short Q&A session. So if you do have questions about the research, please post them in the Q&A forum. And when it's time to get to questions, I'll raise them. I'll sort of curate the list and pose them to James. We'll post links that are relevant to today's presentation in the chat. So monitor that as relevant items pop up. You'll see them linked in chat. So on to the webinar today. This is the final presentation in a special series of RAND policy labs called Rise of AI. RAND experts are studying the implications of artificial intelligence across nearly every policy domain, and we want you to hear directly from them on these topics. I'm very happy to welcome you to today's session on a very important topic: why AI projects fail and how they can succeed. This work was conducted in RAND's National Security Research Division. Then that's the brief background. Now, onto the speaker. I'm happy to introduce James Ryseff, who is a senior technical policy analyst at RAND. He's an expert in artificial intelligence, defense innovation, technical workforce issues, and software engineering best practices. He leverages his prior experience as a software engineer at Microsoft, Google, and other private sector firms. And he applies his technical skills to public policy problems here at RAND. With that, I will turn it over to James. Take it away, James.
Thank you. Thank you so much, Anu. So we're here to talk a little bit about why AI projects fail and what we can all do to help understand how they can better succeed, or most likely succeed. So obviously, lots of people are talking about AI. AI has been seen as this really transformative technology. It's delivered real benefits in the private sector. Various people, people who are tech CEOs, people who are not tech CEOs, people who are policy, influential policymakers, all believe that AI is going to have a very significant impact on the future and on the ability of organizations to achieve their various goals, right? And so with all the hype around AI, I think everyone recognizes just how important this technology is likely to be. But despite all this hype, despite all the expectations that AI is going to deliver these massive gains, there's a lot of people on the actual ground floor who are struggling to understand how they actually practically execute AI projects, right? There's a ton of pressure to do something, just anything with AI to show that you're up on the latest tech, that you're on top of this latest trend. And yet a lot of AI projects are failing. That's something that we're hearing anecdotally, right? One HBR article places the failure rate as high as 80%, right? Twice the failure of other IT projects, a category of project that's already extremely likely to fail, right? So what do we do about this dichotomy? So we in particular wanted to get to the ground truth of what was actually going on that was causing these projects to fail. And so we applied an approach sort of inspired by the Design Patterns book, a classic of the computer science literature, by going out to experienced data scientists and experienced engineers, people who'd worked on a lot of different AI projects, had at least 5 years of experience. And we chose people across a diverse group of industries, not just people at the big tech companies and the FANGs, right? But people at banks, people at manufacturing companies, people all throughout the economy, right? Who could give us a real good sense of what was actually happening when people try to implement AI projects and what was leading to these kinds of failures. So what did we ultimately hear? There were 4 big categories of things that were leading to the failure of projects. And so we broadly grouped these into leadership-driven problems, data-driven problems, tech-driven problems, and sort of a mismatch of processes, right? So let's start with the leadership problems. So the number one thing that our interviewees discussed was that business leaders often don't give them the information they need to understand what problem actually needs to be solved and how they can actually make a difference, right? So what does that really mean in practice, right? So sometimes a business leader will say something like, tell me the price I need to sell my item for, right? The goods that we're selling for. But that can mean a lot of different things. And the data scientist may not have adequate context to understand what that actually means, right? Do you want the thing that causes you to sell the most units, like to move the most product, right? Do you want the thing that maximizes product per unit, right? Even if that's different, right? And so often business leaders sort of give these vague high-level goals, but they aren't actually around to talk through the specifics of what that means. And so when the data scientists make assumptions about what that actually means in practice from their perspective and experience, they may guess wrong. And by the time they realize that they've guessed wrong, it could be many months into the project, right? In other cases, they simply aren't giving enough information. They are not experts in the specific business process that they're trying to optimize, right? And so in many cases, there's sort of a siloing between the actual technical team and the business people, right? And so, for example, just because you say sell more units doesn't mean that you actually understand what are all the steps that actually happen when people in the organization work to sell more units, right? Often also there's assumptions that AI can optimize every part of a business process and completely replace people. In reality, AI sometimes is very good at improving certain steps of the process, even if it can't automate the entire process and remove people altogether, right? And so there can be this mismatch of what AI can actually do and how AI can actually work, and sort of the lofty goals that have been set by the high-level leadership.
Hey, James.
A quick
clarifying question from chat. What do you consider concrete examples of AI projects that might be useful only because it's clarifying? And can you say a little bit about that? Concrete examples of what you're thinking about?
Cases where they're actually helpful. Yeah, so I think
there's examples of what constitutes AI projects. Sorry. So just the scope.
Oh, sorry.
Yeah.
Yeah, so in this case, we were mostly looking at projects that were basically associated with machine learning, right? So things where you have a bunch of data, you point AI algorithms at that data to learn, and they end up generating a model that can sort of automate that process, right? So we didn't simply, although large language models are obviously sort of one of the big topics of the day, we didn't restrict ourselves only to LLMs. We really wanted, sort of more broadly the field of machine learning overall, right? So we don't include things like expert systems. So at this point, expert systems, I think, are just part of the bread and butter of computer science, right? And so while an earlier era of computer science might have considered those things to be AI, we're really talking about sort of the trend, depending on what company you've been in, since sort of the early 2000s, towards using AI models that can be applied to various tasks, right? So things like recommendation engines for say e-commerce, right? Large language models and chatbots, computer vision algorithms. We really included sort of any type of AI model that was sort of newly enhanced in the last sort of 10 to 15 years, if that makes sense. Okay, so the second type of leadership problem or driven failure is when sort of projects are demanded to use AI in cases that isn't really needed, right? So in some cases, you really have a data set where a handful of patterns just simply captures the majority of the information that's there, right? So if you want to know how much, what your crop yield for a field is going to be, it's pretty much related to the amount of sunlight it receives and the amount of water it receives, right? There's a handful of corner cases here and there, but it's not really a problem that you actually need to apply AI to, right? So unfortunately, there's a lot of cases where managers are either sort of looking to show their bosses they're using cool stuff, right? Or they're sort of, I must have complex problems. I'm an important person. My problems must be the type of problems that need AI, right? And so sometimes data science teams are directed to use AI, the more modern AI, machine learning based techniques for problems that simply don't require them, right? That you can simply write a few if-else rules and capture the majority of the value from the data, right? And so these projects are not ones that fail in the sense that they don't work, right? But they fail in the sense that you spend a lot of time and effort for something that didn't really require it in the first place. Third, there are cases where people sort of are over-assume on what AI is capable of doing, right? So orgs will sort of say, just go and add some AI to this thing, thinking that it's sort of like adding leather seats to a car. But, it isn't, you basically need to build this into the baseline. It's not something that you can just sort of say, go add this, right? So The other example is people will sort of get excited about AI. They'll hear that it's like this super cool and advanced technology. They'll read about some really great advancement that like came out of the academic sector potentially. But the data may or may not be there for your organization, right? Or you may have to do a bunch of sort of manual cleanups and like bring a bunch of data in together. They may underestimate the difficulty of getting AI to work in the context that you're actually working in. And so when sort of AI takes longer or when it's less reliable than you sort of heard about on the business article you read, people often sort of lose confidence. So like, oh, why can't my team make it work 90% of the time like that article I read about, right? And so that leads to sort of a mismatch of expectations and a perception of project failure. Fourth, leadership often underestimates the time commitment, right? They often sort of think that AI is going to be easy and fast. And so when AI takes longer than they're expecting and takes a few months or even most of a year or longer to actually achieve the goal that they've set out, they can lose confidence and sort of perceive the project to be a failure, right? In many cases, leadership are sort of rapidly changing their minds about what the business priority is. And so just as the data science team is starting to ramp up on sort of what data do I have, what data is useful, what kind of insights can I get from that data, and starting to think about how they can train a model, they're told to sort of shift course and focus on something else, right? And so that leaves them basically at a dilemma. Either they can continue trying to deliver the thing that they've been working on, been starting to ramp up on. And so when they deliver that thing, the organization will say, that was 4 priorities ago. We don't care about that anymore, right? Or they shift with the business org and they're constantly, oh, this is the priority. Oh, next month, that's the priority. And they're, constantly chasing this moving goal. And so unfortunately, it means that they never actually get the time they need to sort of really dig into the data, to really develop a useful model and deliver a complete solution, right? And so by chasing after that moving target, it means that they never actually accomplish anything, right? So that's a different type of failure pattern that can be caused by that lack of commitment by leadership. Okay, the second major category of failure are things that are driven by failures in the data. So what does that mean? So the number one problem here is that basically data engineering is often perceived as a relatively low prestige activity, right? And yet it's often the thing that actually leads to the greatest amount of success with the models, right? If you have dirty data, if you have sort of data pipelines that like, flake out and sort of randomly drop off, then basically you're going to always have problems delivering reliable AI models and models that work effectively, right? And so the problem is, how do we get good people to do what's perceived as boring work, right? Instead of, the superstars that are, the data scientists who train the model, that's considered the real AI stuff. And the data engineers are often sort of forgotten about and underinvested in, right? That's a significant problem with getting success here. The second problem is data scientists often lack domain understanding. So they're not experts in the specific field that the data covers. They're experts in sort of statistics and how to actually train models and things, but they're not experts in the business processes, right? And so often the people who are subject matter experts perceive AI as a way to automate their jobs or replace their expertise, right? And so they may not be inclined to collaborate with the data science team and give them the context-specific information that they need in order to deliver a good solution, right? So how do we sort of assuage fears by the people who actually know in depth and make sure that the data scientists have that context from the domain that they need in order to deliver and really understand what the data means in the first place? Third, often data wasn't really collected with AI in mind, right? So a lot of data that organizations have was collected more for sort of record keeping purposes, right? Like we want to make sure that the ledger's balance, or, we want to make sure that there's logs about the sort of facts of what happened. But AI often needs a lot more about context and behavior. Like, why did someone buy this item? What were they seeing when they were looking for this item? Not just the record of the fact that they purchased it, right? So for example, was the person comparison shopping between a bunch of items in a similar category, or were they sort of browsing, just sort of exploratory, looking for things that they might, and more of sort of an impulse purchase format, right? If you don't have the right data to understand those differences in behaviors, you might not be able to train a model that effectively drives sales of the item, right? And so you can repeat that in the context for lots of different organizations, right? They may just have the facts of what happened, but not really the context around those facts. And then lastly, a lot of times organizations struggle with unbalanced data, right? So if you're diagnosing, say, cancer, cancer is a pretty rare condition, right? And so you might have a lot of data with no cancer and very little data that has cancer, right? And so generating data sets that actually capture the rare occurrences that you're trying to identify and really sort of work on. In some cases, it's just, you don't have enough of the right types of data to sort of diagnose or to identify those more sort of rare and corner cases that may be the things that really add the most value to what you're doing, right? And so that's a problem that in data that's just somewhat difficult to overcome. So the third category is sort of tech-driven problems, and this sort of ends up manifesting in two ways. So for one, in some cases, the tech team itself, or in other cases, even the leadership team, sort of focuses more on using the cool tech, the latest, the most prestigious tech. We're using the latest OpenAI drop, and we're showing that we're at the cutting edge. We're using these cool tools. And they get so focused on the intricacies of what technology they're adopting that they forget to apply it to a problem that matters in the first place, or they forget to really focus on what business problem will add value to their organization and to their end users, right? And so getting excessively focused on the technical side of things can lead to problems in the end. The second kind of problem is essentially sometimes you choose problems that just either aren't a good use case for AI or they're just beyond what AI can currently do, right? So in some cases, for example, maybe you adopt a model that was trained by academia and that, some, professor is sort of saying, hey, we've made this great advance. It's like scoring really well in this benchmark or something, right? But a lot of cases, sort of practical data scientists find that when you take these academic models, they don't really work well on dirty data sets. They only work really well on clean data sets, right? So if you get, if you're doing like a computer vision algorithm and there's some occlusion on the lens that's taking the photo, or if there's, rain that's sort of distorting the view, a lot of times the accuracy of the model will drop substantially. And those are problems that you encounter in sort of the industrial world that you might not in sort of more the academic world, right? Also sometimes you have to sort of communicate where the tech drops off, right? So maybe there's like 4 things that you really want this AI model to do, and it can do 3 of the 4 really well, but the last thing is going to be really hard and expensive, right? You need that sort of subtle conversation with your leadership around, okay, how important is this last step? Could we just continue to do this with people, or do we absolutely need an AI model to do this thing, right? And so understanding where you might want to use a human-machine team in collaboration, as opposed to sort of designing a model that will sort of work independently, is a decision that requires some context and nuance that leadership may not be prepared for. If they just think AI is this magic, push button, get miracle kind of technology, they may not be ready for you to come back to them and say, actually, boss, it can't actually do this part of the problem, right? So the last sort of category of problem we had is a lot of our interviewees talked about the mismatch between sort of traditional agile software processes, like sort of Scrum or Kanban and things, and the timelines of AI projects, right? So AI projects in particular require a lot of experimentation where you're actually not entirely certain what the outcome will be. That's in 2 different ways. Sometimes, one thing that the data scientists have to do is explore the data to understand what they're even building on top of in the first place. So you can have data fields that look like they're very relevant, look like they'll be very useful, but that you don't realize were being captured by humans who like had inconsistent markings or that they were labeling it in different ways, right? And so a data field that you may have thought you could rely on may actually in practice prove to be unhelpful and something that you have to ignore, right? Or you may just need to dig into the data and get that domain context to understand what the heck you even have in the first place. And so that's an unstructured process that doesn't fit necessarily into rigid sort of 1 week or 2 week kind of timelines, right? The other part of this can come on the other end where maybe you've trained up an initial version of the model, you've got it sort of working at 30%, and your boss is like, okay, how long is it going to take you to get to 50%? So that's something that's a very hard question for a data scientist to answer, right? Sometimes improving model accuracy by 10% can happen very rapidly and can take, weeks or months. But we talked to one person who said, they got the model up to about 50% and they thought they were really on the right track. They thought they were, working towards success. And it took them like 3 years to move the accuracy up another 5% because the data, was just very dirty, very hard to accumulate. And actually improving accuracy on that model just took a long, long time and a lot of effort, right? And so Agile sort of where they're sort of expecting that every 2 weeks you have something done, may or may not be a good fit for these data science processes where you're really just experimenting and see what happens, right? So we're really looking for a new process that really fits the work that needs to be done to train AI models. I think that's something that the industry is still sort of struggling with and looking for sort of a better fit to the work that's actually happening. So this is mostly a policy audience. We specifically talk to people in the private sector that are at sort of a higher level of Maslow's hierarchy of AI needs, right? So this is the Maslow's hierarchy of sort of self-actualization to psychological needs. Most of you on this call are probably much lower in the pyramid relative to the people we talk to, right? So like you're looking to get the right kind of talent, just hire any data scientists at all, having adequate compute to train models. The expectation is that the private sector is really far ahead of the government in this space. And so a lot of you are probably struggling with things that are a little bit lower on the pyramid of needs relative to some of the people we talk to. So basically, as we were doing these interviews, we looked at two things that we thought would particularly help our policy audiences. So one, we asked specifically about compute. So in addition to sort of the more open-ended, like what is causing your projects to fail questions that we asked, we also drilled specifically into whether compute was, being a limiting factor in the private sector. In general, it was not a problem for the people that we talked to, right? Essentially, most people said, if we're able to go to the cloud and if we're able to buy the compute capacity from Amazon or Microsoft or Google or whoever, it's not a limiting factor that causes our projects to fail. There were a few people we talked to, mostly in the large companies that were really working on training their own internal LLMs, Google and Microsoft and people like that. They were saying, we do have a temporary sort of compute shortage, but it's something that they thought would be overcome pretty quickly. That as they were buying more, GPUs, as they were acquiring more hardware, it would be something that would be sort of overcome in the short term. The only people we heard who did say that this was a limiting factor for them were organizations that basically felt like they couldn't transfer their data to the cloud for some kind of security or other reason, right? So like medical data is obviously very sensitive. Some organizations in sort of the biotech or healthcare space felt that they couldn't transfer customer data. Banking, financial data was considered to be sort of relatively secure and needed special security measures. Some of those organizations would say, yeah, we struggle with compute. Like we were sort of running things on a laptop or doing things that, trying to share relatively scarce compute resources. But really anybody that was able to use public cloud was really not running into compute problems. So we expect that would be very different for people in the government space. So we specifically basically didn't focus on government users for this particular study. We wanted to sort of get that sense of what was the next thing that government was going to run into as opposed to the problems that they're facing now. But that's something that we hear in our own sort of RAND studies is a much bigger problem for people who are sort of government or government adjacent. The second thing we asked about was sort of talent shortages. So for talent, there were more of our interviewees in the private sector who said that this played a role. It usually wasn't the leading role. It wasn't usually the problem that caused the project to fail, but it was something that they struggle with a little bit more. So they basically talked about a couple of problems. They said, in general, there's a lot of people out there with a data science degree, and especially as you've sort of had these data science academies and sort of boot camps spinning up, you've got more and more people who have some kind of credential that sort of tags them as a data scientist. The problem is that it's hard to differentiate, like, from people who have these degrees, who's really going to be good at the job when they get there, and who's just sort of like, they pass this quick thing, but they're not going to actually be very effective on the ground. That was sort of one thing they talked about being a difficulty with talent for them. In particular, they said that a lot of their sort of interview candidates lacked real world experience, right? If you got trained at one of these boot camps or one of these more academic programs, often you were dealing with like very clean data. You were dealing with sort of sets, of a relatively pristine environment. And when you actually got into the real world and you had sort of dirty data sets or data sets where the meaning of the data had changed over time, a lot of the practical difficulties that you encounter in industry, a lot of their candidates would sort of struggle to actually sort of get the data in the right shape so that they could actually make meaningful progress with the skills that they'd originally been taught. Another thing that we heard a lot about was sort of a talent mismatch, that basically everyone was sort of looking for the rock star performer who had tons of experience with the latest tech and like the best and brightest credentials. And then similarly, talent is looking for those top tier companies, right? Everybody works for the Google or the OpenAI or like the really most prestigious places. And so you've got sort of 95% of companies chasing the same 5% of talent, and you've got 95% of talent chasing the same 5% of companies, right? And so there's a really large unmet need of sort of people who are below that sort of top tier, not being willing to sort of match with each other and accept and sort of bring on the right kind of talent. And then finally, the other difficulty we heard was that the term data scientist itself is often ill-defined, right? So like in one company, a data scientist might only be responsible for training AI models. In other companies, a data scientist might be more of a full stack role where you're sort of cleaning data, you're sort of working with customers to define sort of the problem, and you're training models and you're doing all these other things, right? And so, basically saying like, what is a data scientist in company A, company B, and company C can often have pretty substantial variations that aren't fully captured by job descriptions. And so it can lead to a mismatch of expectations between a new hire and sort of the company as to like what their role is supposed to be and what their job is supposed to do. So how do we overcome all these problems? So we make 6 recommendations here. So in particular, the number one failure being leadership driven. It's important for leadership to work with their technical staffs and to have the amount of time and informal conversations to help them understand what's the true project purpose and domain context of like what the AI model is going to fit into, right? If you sort of just give these decots from on high saying, make me an AI model that XYZs, you should realize that there's a high likelihood that the technical team is going to deliver something where they've interpreted some of the details of what you actually needed incorrectly. So make time for those conversations and have an ongoing conversation with their technical staff about what you really need and why. Second, leadership should choose enduring problems and sort of, as opposed to forcing your AI teams to sort of jump from thing to thing, you should look for a problem that is something that's going to be an ongoing problem for your organization that's a high priority, and let them have the time to develop effective solutions to that problem, right? To build an MVP, to iterate on the MVP, to deliver 2 or 3 versions of something. And so you can actually deliver something that really makes a huge impact on your users' lives. Also gives you the time to build the infrastructure necessary to keep the model working, right? To refresh with data, to make sure that if a data pipeline goes down one day, that the model doesn't completely fall over, to build up the infrastructure to alert you when problems have occurred. These are all things that take time and effort, and you need to have the attention span to not simply just jump from thing to thing. Third, we argue you should focus on the problem, not the technology, not to get excessively tech focused, right? So a lot of people have said that AI is the new electricity, right? It's not, an end goal in and of itself. It's an enabler that sort of makes everything else around it better, right? And so as opposed to focusing on the latest and greatest models and the coolest and most interesting tech, focus on what the problem you're solving actually is and stay laser focused on that through the end. Fourth, organizations that are willing to invest in supporting infrastructure tend to do a lot better in this space compared to organizations that are sort of constantly moving from thing to thing. So building up data pipelines, building up sort of the sort of more DevOps portion of AI where you can sort of more effectively deploy models, more reliably deploy models. It takes time and effort and personnel to sort of build up things that support it and ensure that your model sort of endures. But it's very essential to making sure that your AI investment continues to last, right? Fifth, make sure that you understand AI's limitations, right? So don't think that you're just going to push a button and get a miracle every time that you start out with an AI project. You need to understand that some problems are not a good fit for AI. And you really need that strong thought partner to say, from the technical side, who can say, hey, we really shouldn't be doing this one. This one's going to be really hard, right? Or say, yeah, that's a really good use case for AI. You should, if we can get the business side of this right, we'll be able to deliver something really cool. And then finally, you need to be prepared for your technical staff to have time to experiment and sort of to explore their data, right? They're going to try hypotheses. They're going to see if things work. And so when an engineer tells you, I'm testing this hypothesis to see, if that'll make a good model, don't expect that the project's almost done, right? You have to realize that these data scientists are going to be trying lots of different things. in a way that is hard to predict which experiment and which hypothesis is ultimately going to pay off, right? And so by giving your technical staff time to sort of explore data sets and to try different hypotheses, you'll end up with a model that's a lot more robust and effective relative to trying to push them to like just sort of try the first thing that works and move on. Great. And with that, let's go ahead and stop for questions.
Thank you, James. A few questions have trickled in. I will ask them, not necessarily in the order they came in, but in the order that I think makes sense given your presentation here. First is a question I have, which is any heuristics for identifying projects that are too hard for AI? You alluded to this a bit. So things like the cleanliness of the data set is something that can affect how feasibly AI could be employed, but any other quick reactions to, deciphering whether something is too hard for AI?
So I'd say a couple of things. So the more tacit knowledge that something's going to need, and often that's related to sort of a business process where a lot of the understanding of like what's going to be work inside that process is held by the employees, right? So the more that something is captured in data and is more objective and sort of something you can maximize, the better off you're likely to be. But the more you're trying to like sort of put a robot in the middle of a process full of humans, right? And the more tacit knowledge that's sort of held by the person who's probably doing the job right now, and most of the time that leads to a more difficult period, right? Because your data set doesn't truly capture all the knowledge that the person is bringing to bear. There's also sort of an ever shifting set of like computer vision problems, right? Like, so there's the old XKCD comic about, tell me if this is a bird, tell me if this is a bird in a national park, right? And like, so the problem is that's changing all the time, right? There are going to be some computer vision problems that are just really hard that we haven't nailed. And then somebody makes an algorithm and they actually nail that one, right? But that's one where there's just a technical, like sometimes like looking at this particular thing is just requires a ton of like there's the classic sort of wolf husky problem. Takes a lot of human domain knowledge to understand sort of why something that looks like has gray fur and looks basically dog-like is one thing versus another. But like the number one thing that I think is tractable is those sort of business processes kind of set up, if that makes sense.
That's great. And it's very related to a question we got from one of the attendees, which is, how would you recommend discerning if a project needs or doesn't need AI? So it's sort of what's too hard for AI, kind of related, versus how do you decide if a project needs it? And you had the kind of the food example, agriculture example, where maybe it doesn't need it. So briefly, could you speak to that? And we'll go to the next question.
That's a good question. That's a hard one to generalize about. And so my advice is really let your data science team use the appropriate tool for the job, but basically don't tell them it has to be an AI project, right? Sometimes they're going to get into the data and they're going to realize, hey, I can get 95% of what you want by writing 3 FL statements, right? And so at that point, so that ongoing conversation between leadership and tech, the tech guys can say, hey guys, I can get this for you in 3 days because I found these 3 pretty clear patterns and that'll get you to the X% accuracy. Is that good enough? Or is it worth me spending a year and writing this complicated model and doing all this data cleaning and doing all this complicated stuff? And, I'll get a 75% thing instead of a 65% thing, but it's going to cost you so much more, right? And so that ongoing conversation of, I've started looking at the data. Here's what I'm finding. Here's what I can do. Boss, should I keep going or should I sort of stop where I am, right? That's going to really lead you to success there. Because there, you really have to get into the data and get your hands dirty to know if there's going to be easy patterns or if you need something more complicated, right? So listen to your data scientists and have that ongoing conversation as opposed to just direction from above, go do this. And I, as the leader, have told you must AI this thing.
Great. A related question is from one of our attendees. It sounds like many of the examples are for internal firm use. For AI-enabled systems that are externally facing, how much are human factors a cause for failure? So, poor human-machine interactions or things like that. Any distinguishing features that might make externally facing projects have different failure modes than centric
So we didn't specifically ask about the difference there. And some of these failure cases were things that were being used by external, so like bank customers instead of bank employees, right? There certainly is a whole set of failure cases that are sort of UI driven, right? But they're not, as far as we could tell, there's not a difference between classic, like I wrote a computer program and it has a bad UI, and I wrote an AI model and it has a bad UI, right? Like there is simply, a certain set of human-computer interaction problems and UX design problems that are just, there always have been a problem. AI doesn't really amplify those. It's the same problem, it's just a different thing underneath, right? And so that's those set of problems. You do just need a good UX design team. You need to do the right kinds of experiments. You need to do all the things that you normally do to deliver an effective user experience. This is really asking the data scientists when things go wrong on your end, like what goes wrong and why, if that makes sense.
Great. I have two questions related to sort of the diagnostics of the failure mode and related project management things. So someone asked, they didn't specify which aspect of the failure they're talking about, but the question is, might failure of these projects in part be caused by poor definitions of what constitutes an AI model? Basically, not drawing the boundary around what the thing is that you're calling the AI model that is at the crux of the project. Could that be a contributing factor to subsequent failure?
Yeah, I think that's absolutely true. And that's where we get to this misalignment between business leaders and technical leaders, right? So a business person might say, go do an AI project to XYZ. And the data science team might say, well, when you say AI project, you must mean these kind of machine learning models, I could have done something with just some basic statistics or some basic if-else's and solved the problem real fast and easy, right? But the data science team is like, well, you told me to use AI. That means I can't do blah, 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 right? So that's why you need these open-ended conversations, right? Where people are sort of willing to sort of listen to both sides and understand each other's perspectives. But yeah, so I think you basically end up having two failure modes there, right? Sometimes business leaders sort of need an AI thing they can take to their leadership. And so if it's not an AI thing, that the goal sometimes is essentially just to do anything with AI to show that you did an AI thing, right? And so that's where some of these failure patterns come with of like, well, okay, we didn't really need to do AI here. We didn't need to spend 6 months and whatever, amount of money to do this thing. We could have just written a quick and dirty thing in a couple of days and solved the problem, right? But then on the other hand, you might have a data science team, again, misinterpret their instructions of, well, the business leader just wanted you to do something useful, but you heard do an AI thing, no matter how complicated it is. And so they go off and they, you could have written a couple of easy, rules and whatever, right? But instead you go down a rabbit hole of looking for the latest and greatest academic research on such and such and come back with this super complicated solution for a model you've never used before. And it ends up going awry. And you're like, well, yeah, I could have done that in a week, but you told me to use AI, right? So that's where the mismatch of expectations can sometimes come in.
Great. Question on project management. So the question is, I understand that we need to give technical staff time to experiment, and Agile may not be the best project management methodology in this context. That said, there's a need for some sort of project management. So what do you recommend for these sorts of projects that isn't the classic software engineering project?
Yeah, so that's something that I don't think we have a good answer for yet. So a lot of the people we talked to, they basically did say, yeah, like some sense of urgency and some sense of timeline is important. That, a lot of our interviewees said, if there was no sense of urgency, then like a lot of my colleagues would just sort of experiment and play around for forever, right? Trying to, see if they could make the model 1% more efficient or cleaning up the data a little more, right? And so you do want to instill some sense of like, yes, we have to deliver a project. There is a deadline that you're working towards of some kind. I think what we really probably need to do in the interim is get back to sort of classic Agile, which is the individuals and interactions sort of constantly talking into each other, as opposed to a predefined rhythm of meetings, right? I think what will probably evolve over time, and so we'll see what happens, right? I think there are phases to a data science project that are different than software phases. And so I think, there's going to be sort of a data exploratory phase where you sort of need to have periodic checkpoints of saying, okay, you started looking at the data, how, what confidence do you have that you understand what data is available, that, how many data sets do you need to continue linking together, what's your data quality that you're running into. And so, having some period of sort of setting up the project for to begin work, having some period of training the model and seeing kind of what your initial training runs produce, and then having some period of refining the model after you have sort of a baseline and minimum viable product established. I will say from what we've seen, or from the examples I've seen, a 3-month rhythm tends to work a little better than a 1 month. So again, people should be flexible and adapt to their own conditions there, because different organizations will have different rhythms. But one very prestigious government project we heard basically initially had this sort of 1 month sprint and sort of agile concept, and they ended up lengthening it to 3 months because basically the 1 month turnaround was too rapid to actually show model improvements, right? And I heard similar things on this project from private sector people. I wouldn't say there's a consensus around 3 months yet, but I do think the consensus is essentially a little bit longer than software milestones typically are, if that makes sense. So we'll figure it out as we go, but from what I can tell at the moment, it's probably something more like a 2 to 3 month timeline for like a big, like, okay, let's see where the model is and actually do a more rigorous set of tests, as opposed to like trying to do like a week or two, the way that you might do in a lot of software projects.
Great. A related question that just broadens the aperture, but sticks to the topic of success stories and illustrations in particular. So in your research on failure, have you found any good real-world examples of successes that illustrate the principles you talk about here? So some of the recommendations you've laid out, have you seen some of those bear out in practice? Or have you heard of those?
Yeah. So we obviously don't want to talk in detail about specifics because we want to protect the anonymity. We promise our interviewees an anonymity, that we wouldn't identify their companies or their individuals, right? I will say that the place where we see the greatest amount of success is where you have some kind of like very objective, objective function that can easily be sort of quantified and maximized, right? So like anything where you're like maximizing profits, or like things like search recommendation engines, where you're sort of saying like how much does the user click on this, how long does the user stay on the page after they do, right? Anything that's much more mathematically quantifiable tends to be things that like succeeds pretty frequently and reliably. The other thing that we see a lot is it helps to have a lot more iterations of the thing. So for example, like a quarterly forecast, you're only going to do 4 times a year, right? But like every day, people are clicking on stuff on a website. And so you're getting a lot more cases, a lot more rapid feedback. So things with sort of shorter iterations and more rapid sort of feedback loops are areas that tend to develop more rapidly, right? And then, beyond that, I mean, a lot of it is very organization specific. And so I wouldn't want to say like, oh, we talked to somebody at JP Morgan Chase and they saw blah, 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 right? So that we try not to get into the weeds of the details there, but overall, those are the types of applications that tend to work the best.
Great. And once again, without delving into details of specific companies, if you could answer this one broadly, apart from data custody concerns related to cloud infrastructure, like your example of a bank needing to train a model on premises and so on, did participants report other regulatory or compliance obligation related hiccups?
Yeah, so a lot of times they talked about internal data security measures that basically, so often you might have more data available in your sort of training environment than you were actually able to access in a production environment, right? So sometimes people were making like synthetic data where they might have like the user's location, right? Or they might have various data about that sort of were more informing them about the person in various ways. And then when they went up into production, they might not have, so either that was being collected by a different production system and they hadn't done the pipelining to make sure that data would be accessible in the production instance, or there were kinds, GDPR or other things might make it so that you can't routinely access that data, right? And so there were a lot of cases where basically people would train a model and the thing that was really powering the model was restricted or regulated in some way that it was unavailable up in production, right? The other thing they talked about is sometimes like you would work on sort of a subset of data. And so like maybe that subset just for random reasons was all in the United States, right? Because of how the data set had been selected. Now you put it up in production and all of a sudden it's all of world. And so your model works really well for the United States, but Italy or China or whoever like totally doesn't work because it's a completely different context, right? And so sometimes it wasn't even that there was a regulatory reason why the data was bad. It was just it wasn't a correct sampling method that had gotten you it was what your company was doing 3 years ago, but you've since expanded into new markets, right? Or, you took a data set selection from during COVID times and now we're not doing that anymore. And so your initial training runs looked really good. And then you put it up in production and it totally doesn't work.
Great. Again, sticking to this sort of aggregate level, not needing to sink into details, are there business fields that appear to have extended their portfolios to AI projects with more success than others? Any comparative advantage or a use of such advantage to seem to be doing better as a group, an entire field or subfield?
I don't know about a whole field. I mean, obviously, e-commerce is probably the biggest field that has gotten this, because it has a lot of the characteristics that make AI projects successful, right? Rapid iterations, sort of a lot, in e-commerce in particular, the user's under a lot of sort of digital surveillance, right? Like you control the whole environment. You can see what they're clicking on. You record a lot of things about their behavior, right? And so, and then it's also a very quantifiable, like we want to make more money, right? Like the objective function is to maximize revenue per user or some other relatively quantifiable goal, right? So things like that, we've obviously seen a ton of sort of promise around, or like digital advertising, e-commerce sales, things like that, right? So within other industries, I mean, I think it depends a lot on sort of some things that you do can be quantified that way, and some things you do can't be quantified that way, right? And so I think that's where you start to get to more mixed successes. And I think in a lot of these other industries that are more real world as opposed to fully digital, I think that's where we're going to see a lot of appeal of like human machine teaming, right? Where I think right now the too many people sort of assume that AI is only good for completely replacing people. I think what we're going to see is a lot of industries sort of evolving over time to realize AI is good at some portion of the task, or it's able to sort of do certain things that humans overlook, right? There are certain things that humans are just cognitively just don't focus on or weaker at, or things they don't reason as well about for whatever reason, right? And so AI sort of working to overcome some of these weaknesses and limitations, but partnering with humans on the things that humans remain sort of effective at, right? I think that's something that we're going to see more and more in these industries that are sort of less typical of sort of the original use cases for the machine learning AI.
Great. I have a question that's sort of two parts. I'm going to blend two questions together. They're very related. You touched on government or DoD versus private sector use. So can you speak to any additional challenges that government organizations might face when it comes to leveraging AI for their missions as contrasted against the challenges in the private sector? And I guess I'll just read the second part too, which gets a little bit more specific. Things like, can you speak to government regulations, geopolitics, kind of the policy window or the state of policy, how those things might influence the success or failure of AI projects in arenas like national security and DoD applications?
Yeah, so that's a great question. So we really should repeat this study specifically on DoD and U.S. government applications. So, if you're a funder with money to burn, we would certainly love to do similar work specifically in this context. So that being said, I've certainly done other studies, and I've talked to a lot of government agencies about these kinds of problems as well. And so here are my opinions that are not as fully backed up by data as our full study here. But I think one thing that really challenges government is the acquisition process and the sort of agent principal problem that it introduces, right? So government has a difficult time recruiting internal talent, and a lot of its technical talent comes from contractors, right? And so essentially, most of the private sector people that we talked to here were the internal data science team for the company trying to build AI for its own use, right? and so it was much less common that you brought in someone from the outside to train the data science model that didn't directly like work for your organization, right? And so writing an acquisition proposal and contract and solicitations and all that, going through the whole government contracting process adds a whole level of complexity here where you have to make sure that you get competent people, that you're getting good technology, and you have to write your documents in a way that will that you tell them, here's what we're trying to achieve, here's what we need. So that whole step obviously adds a whole level of complexity that private sector organizations often don't have to deal with, right? I think that's probably the number one biggest challenge for government relative to private sector, right? So number two, government has been slow to adopt cloud, and that means that they also have stored a lot less data relative to private sector organizations, right? And so the amount of data that you can access, the number of silos. So like in government in particular, you're often like bringing data sets together from many, dozens of different systems in order, so I was talking to a Marine Corps person one time that, when a soldier is, an enlisted personnel, but then they get promoted to sergeant and they become a non-commissioned officer, they get put in two completely different personnel systems without a reliable key to sort of join between the two, right? Repeat that across a whole bunch of, so government data is a lot more siloed across many more sub applications, typically relative to private sector, right? And so that is going to add a whole bunch of challenges, I suspect, into most government organizations and their ability to sort of get enough data and get enough context around data to really train effective AI models in the first place, right? So there's a lot of things in government. They're supposed to be these objective, quantifiable processes. And yet I think it's going to be very difficult to train AI in a way that AI, those should be really great use cases for AI, right? But getting enough data and getting the right data to train AI effectively on those use cases, I think, going to be a huge challenge for government. And then moving that data to a place where you have the compute power to train an effective model is a whole nother sort of set of hurdles.
Great. We're nearing here the end of our time, but there's, I think, probably time for one or two more questions. I'll ask you one, and if there's a final question someone wants to post in chat, this is your chance. So from your survey, were there application categories that initially seemed like good matches for AI, but turned out to be surprisingly poor choices? So any kind of bait and switch that they reported?
That's an interesting question. Not that we really heard. So we didn't hear patterns from our data scientists that really sounded more like that. I think it was usually more just business leaders with big dreams. And the problem was that was very person specific, right? The business leader reads some article or sees some presentation. And so they're all seeing different ones. There's so much AI content out there that they get, this sales firm or this consulting firm comes by and makes a pitch, and now the business leaders all, into it. It was really more driven by the hype cycle as opposed to the problem type. And so people were sort of being baited by different types of things, but there wasn't so much of a pattern as to like what the bait was, if that makes sense.
Yep. And I think I'm going to ask one last question, which is a little, it's broadly worded, but I think you'll be able to understand. I think, so what about failures that are related to agents? I think you said, machine learning is the primary focus of how you were scoping this. So any differentiating features there when you're talking about agents?
Yeah, it's a good question. I think agents were too new at this point because we were talking to people they had like a lot of experience. I think the agent related failure patterns are going to be emerging as agents become the real growth area for AI. But that was sort of too new an application for AI to really show up in this study. So we concluded the research on this a little more than a year ago. And so at the time, agentic AI was sort of emerging, but hadn't really emerged to the point where we picked it up here. So we really should repeat the study, say, a year from now, and I think we would hear a lot of agentic AI failure patterns.
Great. Well, thank you, James, for a great presentation. Lots of questions that came through here. Appreciate you taking the time to do this. And thanks to everyone for joining us. If you're not, or for those attending, if you're not on our mailing list, please sign up to receive the RAND Policy Currents newsletter and NSRD's upfront newsletter, the links to which Karen's going to be posting or has already posted to chat. And then before you all leave here today, we have just one simple poll question that'll pop up when I'm done talking, or maybe as I'm talking now. If you could please answer that, we would very much appreciate it. Thanks again for joining us, and we hope to see you at our next Policy Lab event. Thanks all. Signing off here.
Thanks so much for attending all.